Hello everyone. Here we discussed Norton's theorem. Basically, this theorem used for two-terminal linear bilateral network. As we discussed earlier, the Thevenin's theorem, both the theorems, Thevenin's and Norton's theorems, can be used for DC network and AC networks. And here we discuss this theorem only for DC network. So let's see the theorem. This theorem basically states that any two-terminal linear bilateral DC network containing energy sources, it means independent or dependent sources, and resistors can be replaced by a current source in parallel with resistance Rn. So if you replace an active network by a Norton's equivalent, and you can see this AB is the load terminal, and if you connect a variable load to this Norton equivalent, then you can calculate this load current by changing this load resistance, and by keeping the values of Norton equivalent will be same. So let's see the calculation of this load current. This is our load current IL. You can calculate this load current by the formula IN Rn divided by Rn plus RL, where IN is the Norton's equivalent current and Rn is the Norton's equivalent resistance. Here we discuss how to calculate this Norton's equivalent. First we calculate Norton's current, that is IN. For calculating the Norton's current, we will remove the load and short this terminal AB, and this short terminal current IN is defined as Norton's current, or you can say this is a short circuit current at terminal AB. So it is defined as IN or ISC. Now let's see the calculation of Rn, that is Norton's equivalent resistance. It will be calculated for independent source circuit and for dependent source circuit. So first we see for independent source circuit must contain only independent sources, for which we will remove the load, and this for this load terminal we will calculate the Rn, and for calculating the Rn we will see the equivalent resistance looking back to the terminal, while all the independent sources are replaced by their internal resistances. It means voltage source become short circuited and current source become open circuited, and the load terminal become open. Then we will calculate the Rn. For dependent source circuit, Rn will be calculated by two methods. In method 1, we will remove the load and all the independent sources are replaced by their internal resistances. It means the network containing only dependent source and network resistances. For this we will calculate Rn. For calculating the Rn, we will connect a source. It may be a voltage source, or you can connect a current source. So by connecting these sources, these are the DC sources, you can say this is a V volt source and providing a 1 ampere current, or you can say this is a 1 ampere source having terminal voltage V. So by connecting any of one sources, we can calculate Rn. Rn will be defined as the response at that terminal, that is V by 1, that is V by I. So by this calculation we can calculate Rn. For method 2, in the calculation of Rn, we can relate any two-terminal linear bilateral network can be transformed into a Norton's equivalent, or you can say into a Thevenin's equivalent network. These two equivalent can be correlated by source transformation. You can see A current source in parallel resistance transform into a voltage source in series resistance. So here we can say this VTH is equals to I into R, that is IN into Rn. Here this VTH, you can say it is open circuit terminal voltage. This IN you can say is short circuit current, and this Rn or RTH you can say an equivalent resistance R. So for dependent source circuit solution, this Rn or RTH can be calculated by VOC divided by ISC, or you can say VTH divided by IN. So by this formula you can calculate the equivalent resistance for the dependent source circuit. Thank you for watching the concept. Please like and subscribe my channel.